Hi, welcome to another episode of SETI Live here from the SETI Institute. I guess it's Facebook Live. Is it Facebook Live, SETI Live, whatever? It is live, and that's been the problem all along, because having live presenters mean there are going to be mistakes. Anyhow, I hope many of you are not watching on your cell phones, particularly you young people. I'm sure you've read the stories about how watching cell phones all day will, in fact, scramble your brains, turn them into the consistency of hot oatmeal, and possibly cause retinal cancer. So don't do it. In my day, we never looked at our phones because our phones were at home wired to the wall, so we couldn't do that. We did look at a lot of clay tablets. Today we have Michael Busch here. Michael Busch is an astronomer right here at the SETI Institute. Michael, you're a principal investigator of Planetary. So how would you describe yourself?
Let's just go with Planetary Astronomer.
Planetary,
as opposed to going through everything that's on all the paperwork.
Oh, yeah, the paperwork. Okay, and we're going to talk about this new, very interesting comet with the appealing name of...
It gets called Comet Borisov. After the discoverer, you'll also hear it called Comet C 2019 Q4, which is less memorable, but it's a unique catalog number.
Okay, this comet, when was it found? This year?
So this was a comet discovered by Borissov, who's an engineer and amateur astronomer based in the Ukraine. He found the comet on August 30th of this year, so just over 3 weeks ago now.
All right, but he's an amateur.
Yes.
But was he using one of his own telescopes?
So for the last several years, he has been building telescopes. He's a skilled engineer. He built a telescope with a 65-centimeter aperture, which is, I guess, a bit over 2 feet for those who don't use metric. And with this, he has been looking at parts of the sky close to the sun, early morning, early evening, when normal astronomical surveys tend not to do as much work.
Now, how did he know it was a comet? I mean, you look at the sky, whether it's early morning or not, and you know, with a telescope that big, you're going to see a lot of stars, right? And you know, well, how does he separate the comet from all the background crud, the stars of our galaxy?
So you take a series of images spaced over some amount of time, a couple of hours, typically, of a particular part of the sky, and you look for anything that moves. Now, most of the things that move in the sky are stuff in our solar system. There's all these annoying satellites and airplanes and birds and whatever that fly overhead.
Birds are particularly annoying.
And then you get solar system objects, near-Earth asteroids, which I study, are to Borissov uninteresting foreground. He wants to look for comets, so he finds things that are moving on the plates at speed typical for comets, and then also looks for tails coming off of them. So we see comets with tails because comets contain a lot of ice, and they come into the inner solar system. That ice evaporates and sprays off into space along with any dust that it may be carrying, and that gives a big tail behind the comet.
Okay, but comets are not rare. People have been seeing comets for thousands of years, probably hundreds of thousands of years. They just didn't write it up 100,000 years ago. So, but this particular comet is in the news because it has some unusual properties, or at least one very important one.
It is a stranger from the outside, yes.
It's come to us from where?
So it came from Interstellar Space. Borissov, again, is a skilled amateur astronomer. He's found 7 other comets before, over the past several years. All of those were within our solar system, on orbits gravitationally bound to the sun. He reported this one. Other astronomers started observing it. But 2 weeks later, it had been observed by people in 15 different countries, all in the northern hemisphere, because it's visible from the northern sky right now. You can't see it if you're too far south. And it became clear this thing is not on an orbit that is gravitationally bound to the sun. It came from interstellar space, and it will loop around the sun and then go right back out into interstellar space.
Okay, but just the fact that, okay, it's interstellar, its origin is, its home, if you will, is somebody else's solar system. But how does a comet leave its solar system? As I said, we have probably 1 trillion comets in our solar system, and they stay at home. They're like home cats, household cats, right? They don't walk out the door and disappear, right? So how did this comet get away from its own solar system?
So as you make the comparison of comets and cats, there's a saying among comet astronomers that comets are like cats. They have tails and do exactly what they please. Every so often
comets don't have fur balls.
We do see comets leave our solar system. Many of you may recall back in the 1990s, a comet called Shoemaker-Levy 9 passed very close to Jupiter and got shredded to pieces. If you have a comet that passes a bit further away from Jupiter, it doesn't get shredded, but it can get gravitationally kicked, sped up or sped down. Like we do when we're sending spacecraft to the outer solar system. We fly them by Jupiter, and Jupiter's gravity flings them out of the solar system completely. Like the Voyager spacecraft that are out into interstellar space and they're not going to come back. We see comets that get kicked out of our solar system and keep on going.
Okay. So
we see gas giant planets around other stars, and thus it was long been expected we should see comets from interstellar space at some rate. But just until the past couple of years, we hadn't seen any. Now we have seen 2 objects come into our solar system from the outside.
But could that not just be the fact, or a consequence of the fact that now we have the ability to see these things that's far better than what we might have had 10 or 20 years ago?
If you go more than about 25, 30 years ago, CCD cameras were not anywhere near so available. People used to find comets just with their eyes or with photographic film, which are not so sensitive. So we are far better at finding comets now.
Okay, and we found 2 in 2 years, right?
So 2017, a very small object called Oumuamua was found by the Pan-STARRS survey, which is a professional astronomical survey run out of Hawaii, on Maui. They found an object about 100 meters long, which is pretty small as compared to Borissov, which is several kilometers across. And they found it as it passed quite close to the Earth, and it flew back out into interstellar space. Borisov is much bigger. It's putting out a lot of gas and dust, so it's got a big tail coming out of it. And it was found when it was 3 times further away from the sun than we are. It's getting closer. It'll loop into about twice as far from the sun as we are, and then loop back out into interstellar space.
Okay, but let's get a couple of things out of the way, because this is interesting from several points of view. Obviously, from the point of view of astronomy, the fact that we've had 2 of these interstellar comets discovered in 2 years must mean that this is a very, if you will, common occurrence, that things get kicked out of the solar system, right? But the other thing is that there's some people who think, well, maybe Oumuamua in particular wasn't really a comet or an asteroid. It was some sort of, interstellar spacecraft. We'll get back to that. It sounds like you're skeptical, or at least it looks like you're skeptical, but we'll get back to that. That's an interesting thing. The first thing, though, I think that if you brought this up at your local Denny's, Michael, I think that the person in the next booth would ask you, first off, well, is this comet going to hit us? And we know the answer to that, right?
So initially, the discovery of the orbit was pretty uncertain. As of September 10th, when it became clear this is in fact definitively interstellar, it was predicted that Oumuamua would pass a bit more than 1 astronomical unit. So this is between us and the sun, away from Earth at its closest approach. So that's 151 million kilometers, 93 million miles at a minimum. We now know it's actually going to be a bit more than twice that far away.
Okay.
So it's going to be 300 million kilometers, what is that, 186 million miles away from here at the closest approach.
Okay, so it's not going to hit us.
Nowhere near us.
I mean, this is
on the scale of the solar system. On the scale of interstellar space, it's very, very close.
Well, all right. Well, yeah, but this thing is about, it's the size of, I don't know, downtown Baltimore. But it's not, it's not going to hit us. But if it had, I mean, that would be very serious, because that's the size of the object that wiped out the dino.
The size estimate here, best available right now, is from a group of astronomers led by Karen Meach. They estimate the size of Borissov is between 2 and 15 kilometers across.
Yeah.
So it's a few miles wide.
Yeah. Okay, fair enough. Can anybody go out and see this already? I mean,
so
obviously,
if you've got good amateur astronomy gear, you can see it. But right now, it's quite close to the sun in the sky. So it was discovered by Borissov when it was about 38 degrees away from the sun on the sky. So if you're looking near the sun, you won't be able to see it more than a couple hours away from sunset, sunrise, because it goes below the horizon.
How about in December when it's closer to us?
Then it gets very much more observable. So we can expect better imaging with adaptive optics telescopes in the middle of October. And then as it loops around, it gets further away from the sun on the sky and closer to us. Closest approach is December 27th at 2 astronomical units.
Christmas comet.
It will be very, very nice time for high-resolution observations, optical infrared telescopes. Then it moves to the southern hemisphere and gets further away. So people, Australia, Chile, Argentina, South Africa, New Zealand will have the last chances to look at this thing.
Okay, now the amateur found this with a...
Which is unfortunately during their summertime, so the nights will be shorter for them.
Well, that may shorten their observation. They're observing pleasure slightly, but nonetheless. Now, this thing being discovered several weeks ago now surely has been the target for a lot of astronomical observation. What have we learned about the properties of this object?
So we have now a bunch of optical imaging, so we can say it is a comet. It's putting out a fair bit of dust and gas, we presume. The tricky part, though, is it's still very close to the sun on the sky. So the Hubble Space Telescope, for instance, can't be used to look at it, because in order to protect Hubble from scattered light inside the telescope burning the detectors, they don't let it point very near the sun. There is a proposal for several hours of time with Hubble as soon as Borissov gets far enough away from the sun to look at it.
But do we know anything? I mean, does it have the right color of a comet?
So there is a spectrum that's available. We take the light from the comet, we split it apart into different colors, and we compare that to other things that we know about. It looks like certain types of water-rich asteroids in the outer part of the asteroid belt, like comet nuclei that we see in our own solar system. So chemically, it's fairly similar to comets, some asteroids that we have here.
Will it be close enough that we can actually make an image of it with the kind of telescopes we have here in orbit or on the Earth?
So right now, you'll see all sorts of fancy high-resolution artist depictions. Those are not real. What we have right now is just a fuzzy blob with a bit of a tail. And this will get far, far better as it gets closer to us and also further away from the sun, so we can look at it later at night, higher up in the sky, and adaptive optics images can be made. Those will have much higher resolution. You should be able to see the dot that is the nucleus of the comet and then the extended emission from the tail.
One thing that struck me when I heard about this comet for the first time was that it was found by an amateur. And, you know, there was a time, and it wasn't very long ago, when most comets were found by amateurs. I remember reading about, you know, all the amateurs in the, well, on the islands of Japan that would specialize in this. In fact, a lot of comets have Japanese names because of this. They would get up early in the morning before dawn and go look in the ecliptic, you know, not too far from the sun with their binoculars, looking for comets. But, you know, the professional astronomy community has developed better instrumentation for finding comets. Is this the end of comet discovery by amateurs? I mean, obviously this guy did it.
So most comets are now getting found by large astronomical surveys, but those look mostly during the darkest parts of the night because that's the most efficient time to look at stuff. They don't tend to look near the sun on the sky, both because you find more things in the darker parts of the sky, and it's also dangerous for a really large telescope. Lots of scattered light bouncing around. You can heat up the detectors and burn them out. So Borissov has been very sneaky and looking at areas of the sky where the surveys don't usually look, and thus he has found a half a dozen comets.
In the old days, they would name the comet after
8 comets now.
Okay. How many of them are named Borissov?
All of them are named Borissov.
Oh, well, that's great. Okay.
This is why we have C2019 Q4 as to distinguish it from the comets he has found other times going back to 2013.
This guy has a legacy.
He has quite a large number of them.
Okay, all right. Now, one of the most interesting things about this comet for me personally, and you can read about this on our website if you want to. And by the way, our Director of Communications, Rebecca McDonald, is sitting with us here in the Commodious studios from which we're broadcasting. And she is happy to take questions from you. You should grill this guy like, you know, like a cheese sandwich and ask him those things about this comet that you've always wanted to know. And he's an expert. You look at these kinds of objects, mostly asteroids,
yes,
I think. But you use radar
yes.
to do that. Is that going to happen with this
So
object?
that was a little bit frustrating, actually. So initially, the predictions were for Borissov that it would be a bit closer to Earth than we now know it will pass. It would be further away than we had thought. Had it been closer, as we initially thought, then I might have been able to observe it with the team of astronomers that I work with. We would have used the Arecibo Observatory in Puerto Rico and tried to look at it. But it's further away, and it's going to be just a bit too faint for us to look at.
Any improvement as it gets closer?
So even at the closest approach, we now know that closest distance is further away than we initially thought it was. So we cannot observe this one with radar. There will be some attempts, I hope, to look at it with radio emission. We do this done some with comets. We can see water vapor coming off the comet. We can sort of track out how material is getting ejected as the thing spins. That may be possible with Borissov as it gets closer. People keep an eye on that.
What about catching up with it with a rocket? You know, some sort of probe.
So after
look at it up
after
close.
Oumuamua got found 2 years ago, people studied this problem. It's very, very hard because these things are traveling fast. The average speed of something just in the interstellar space moving relative to our solar system is far faster than the Earth's speed around the sun. So to get catching up with one of these things, you not only have to go fast enough to escape our solar system, you have to go another 30 kilometers per second faster than that. And that's just to match the speed of Borissov. To actually catch up to it, you have to go even faster still. But people have looked at this. There's a group called the Interstellar Initiative that has been studying this sort of problem the last couple of years. According to their math, you can catch up to Borisov, if you launched a spacecraft a year ago.
Yeah, well,
This is like problem because we don't actually have launched a spacecraft a year ago.
This guy's dead now, but if we had only treated him a year ago, he'd be alive. I mean, what
Time
good is it to say that?
Time travel is not terribly useful. There is a
Oh,
project.
it's very useful. It's just
There's a project called Comet Interceptor,
Excuse me.
which has been approved by the European Space Agency. The idea here is to build a spacecraft and park it in high Earth orbit. And it will sit up there, and it's designed to be able to do that for several years, and it will wait until either a long period comet from the outer part of our solar system or another interstellar object comes through that it can reach. And then they'll light up its rockets and send it to fly by the object.
all right.
Unfortunately, they have not yet built that spacecraft, so we cannot catch up with this one.
Yeah, is somebody willing to pay for it, by the way?
ESA has approved the project.
All right.
So thank you to the European Space Agency. If you want to catch up with Borissov in particular, there is a way to do this, but it takes until about 2045. And you'd have to use the largest rocket we've got and send the smallest possible spacecraft, so you might get one picture.
Yeah, that
I
sounds
don't
like,
think it's really quite worth it.
that's an,
Wait for the next one.
an expensive subject. Well, now, I want to get on to that because it was said, I apologize, I had a cough last week. It was said when Oumuamua was in the skies by none other than the head of the Harvard Astronomy Department that there was some not negligible chance that that wasn't an asteroid. You can't doze off here, right? There was a non-negligible chance that that wasn't a natural object at all, but if you could only get up close to it, you could see the portholes and the little green faces behind it. Now, one of his arguments, well, we'll get back to one of his arguments in a moment, because this is, to me, an interesting thing. I think that this second comet has something to say about the possibility that these are not nature. But first, I just want to read off the list that Rebecca has compiled here of some of the people who are watching. They're all over the place. Manchester in the West Midlands in the UK, Mars. Welcome to all the people on Mars.
Wait a minute. I see we couldn't have gotten back here and back by now.
Yeah, I think these people are joshing when they say Mars. They probably meant the moon. Portugal, Washington, D.C., my cell phone. Where's that? Sao Paulo in Brazil, Munich, Norway, Orlando, Florida, Fresno, Czech Republic, Lecompton, Louisiana, Puerto Rico, Surrey, Derbyshire. Lots of people from the UK watching. Why are you watching this when you could be paying attention to Boris Johnson? Budapest, L.A., Magador, Ohio, Australia, Istanbul. Well, that's a worldwide audience, and justifiably so. Okay, let me just get back to this point because to me it's one of the most interesting things about this. The argument that Oumuamua might not be, really a rock, as the artist's depictions always showed it, but in fact, if you got up close, you would find it was a stainless steel cylinder with portals or something like that. One of his arguments was that, look, this thing came right into our solar system. It goes around the sun and leaves, as this new comet is doing. And what are the chances that somebody, some random comet kicked out of somebody else's solar system is so precisely aimed as to hit us that, near to the center, right? It's like putting a dartboard target 20 miles away. I throw a dart and I hit the bullseye. It's not very likely, right? But does the fact that now we have another one of these suggest that, well, doggone it, there are just lots of these babies out there, and of course some of them are going to, by chance, get close to us.
So there's a really big selection effect here. We only see the things that are close enough for us to find. So Oumuamua passed, I guess, 15% of the distance to the sun from us. We could not have seen it had it been further away. So something like that could be flying by right now and we wouldn't see it if it's further away than that closer distance. Something like Borissov could fly by at that distance once every 20, 30 years, and we wouldn't have seen the last one. So Oumuamua looks like a rock. Didn't outcast terribly much, looks like a rock. Borissov looks like a comet, like we see in our solar system, chemically. There might be interesting things showing up if we can get the detailed isotope ratios and people do fancy geochemical analysis. But that will need to wait for it to get further away from the sun so we can get closer looks at it. But they look like asteroids and comets are just randomly spread throughout interstellar space, and every so often they happen to come into the inner part of our solar system.
What if we found another one within 2 years? Would you say, yep, there are just a lot of them out there?
Pretty much.
Yeah, okay.
And they aren't precision targeted. Borisov is 300 million kilometers away from us.
Well, wait a minute. Isn't that a little bit self-centered? I mean, maybe they're not here to look at us.
Well, they're not going near Mars either.
Oh. That's the only other interesting place in the solar system.
They're not really going near much of anything, except they just whip around the sun and go back out.
Yeah, it seems like a very short visit if it's a deliberate visit, doesn't it?
And likewise for Oumuamua, it didn't go near anything in particular.
Okay.
These are the ones we can see. Presumably there's more stuff further out that we get better telescopes, like the Large Synaptic Survey Telescope being built down in Chile right now. We'll find a lot more of them.
All right.
And then instead of 2 per year, maybe it will be a few per year, maybe it will still be only 1 or 2 per year. We've gotten lucky right now. I don't know. We'll see. We need more data.
Well, it sounds like even though you're a member of a solar system, you're not a permanent member. They can kick you out at any time. It's like the clubs I belong to. Okay, here are some questions from you. David writes, do we have any idea where this comet came from? I mean, interstellar space, but, space is big, very big, and, we know the direction, right?
We can track its orbit backwards as well as running it forwards. Right now, there's still some pretty big uncertainty in that, because we've only been staring at Borissov in particular for 3 weeks. Things are better than they were after the first week and a half, because we've got twice as much time looking at the comet and a lot more observations. After this next year, when it's looped around the sun and gone back out again, we'll have the best possible knowledge of where it came from, and people will try to run its orbit back. But there's uncertainty in how well we know that orbit, and there's uncertainty in how well we know where all the stars are moving. So the Gaia spacecraft is tracking the motions of roughly the 1 billion closest stars to the sun, although the outer edge is tracking the brightest ones and missing the faint ones. But it's tracking lots and lots of stars out to many hundreds of light years away. But we can only run their orbits backwards so well. We only run the comet's trajectory backwards so well. I say orbit here is orbit around the center of the galaxy. And you end up with, maybe you can run the orbit back a few, maybe 10 million years. But this thing's probably been in interstellar space for 1 billion years, because the galaxy is 10 billion years old, give or take. The thing probably got ejected at some point in that period. It's been in space for 1 billion years. We can only track back 10 million years. The odds are better than 99% that we're not going to be able to say where it came from.
We're not going to pinpoint. If you could only catch up with it, which you
and the same applies to Oumuamua.
Yeah.
They came from very different directions.
Maybe they have brass plates on the side, made in, and then some catalog number there. Well, okay, fair enough. We're not going to know where it came from. By the way, just for people who are unfamiliar with the kind of numbers we're talking about here, this thing is moving at the speed of 33 kilometers per second or something.
That's how fast it was going in interstellar space as it came into our solar system.
Well,
as it falls through the sun's gravity, it gets sped up to almost 1.5 times that, and then it will slow back down as it flies back out.
Okay, but let's take interstellar space. So it's moving at 33 kilometers per second, which would be great for you on your next vacation, because you would get there very quickly. But on the other hand, even if this came from the nearest other star to us, which it didn't,
it takes about 9,000 years to go 1 light year.
Yeah. So
Proxima Centauri, the nearest star, is 4.3 light years away right now.
Okay, so there's 40,000 years.
At a minimum, and probably many, many times that.
So if this is really an interstellar probe, I hope the food on board is good. I mean, that's just not fast enough. All right, here's a question from Adam. What is the time frame before it passes us on its return from the sun? All right. Well, does it get any closer when it's coming out?
This is a little tricky. Right now, it's about 3 times further away from the sun than we are. At its closest approach, it'll be just over 2 times further away from the sun than us, and also roughly the same distance away from the sun. So it's not going to get that much closer to us or to the sun. What will happen is that where it is on the sky changes, so rather than the sun being here and us being here and the comet being here, the comet will be over here, and it's easier for us to see at nighttime, and we get better data.
Okay. So if it's on a mission to visit our solar system, it's not going to any of the tourist attractions.
The comet just flies in, sprays off a bunch of gas and dust, and flies back out again.
Well, what's the future for this comet? If it keeps, mind you, the chances that it's going to do that for another solar system are not necessarily great. So it doesn't slowly evaporate into nothingness.
You could probably work out the lifetime on this. Maybe it survives 100 passages through solar systems, okay, and it flies through one solar system every 300 million years or whatever the number ends up being. I have to work it out.
Yeah.
It'll be something like that. Then give it another
10 billion years.
30 billion years, and we'll no longer have this comet. But I don't plan personally on that time scale.
You don't have the mortgage I have. All right. By the way, I want to remind you, it's still not too late to send in your penetrating questions about Comet C 2019 Q4. Couldn't they come up with
Borisov.
Borisov. Well, Borisov is a better name, although maybe not for Americans. Right. Okay, so we have a second interstellar comet. Now, some people are going to ask, well, so what? It doesn't seem to look any different from the kind of comets we can find very nearby, right? I mean, even Halley's Comet has many of the same properties, including more or less the same size, right?
So this actually is an interesting question. It has a similar composition chemically, we think, to comets in our solar system. What does that tell us about how other solar systems change with time and form and develop? Do we always get similar comets all over the universe? I don't know. Or are we just happening to get the one that's the same? So this is another reason to find more of these things. When we have more objects, we'll be able to say what is normal and what is strange for comets elsewhere in the universe.
Right. But what could you conceivably learn by studying somebody else's comet? I mean, maybe their solar system was built a little differently than ours was?
So we can get stuff about how comets form and evolve. We have the Oort cloud in our solar system. One way you can eject comets from that is just stars passing by on the outside. Do Oort clouds form similarly among other stars? That's a good question. Nobody really knows the answer. So you sample things that got ejected out of Oort clouds or got kicked out by comets. It's comets that kicked out by planets in other solar systems. Maybe that'll show up as two different sorts of interstellar objects. I don't know. We should find more of these things.
Yeah, well, spoken like an astronomer. But I have to say, is there something, I don't know, philosophically, that's maybe too heavy a word, comforting about learning that this object, which may have come from many light years away, and certainly some light years away, looks like things that are nearby. In other words, whatever stellar system this comes from, they also have comets. They have comets like our comets. And that might even be important to the emergence of life, might it not? Because it's thought, or at least
one of the ways for getting water to the Earth 4.4 billion years ago is to drop a whole bunch of comets.
Yeah.
So similar stuff being available in other planetary systems, maybe that's useful for the people who talk about astrobiology.
Yeah. Okay.
But again, we only have so much data here. So we should learn more.
Yeah, but you can be prescient. I mean, to me, there is this comfort, and something familiar from many light years away. And it was like when I was a kid, when I found out that the neighbors had carpets with patterns in them. I said, my gosh, we have a carpet with patterns in it. I mean, it was astounding to me. Do we have any more questions here, Rebecca? Okay. All right. Well, listen. You're in the business of studying these small rocks in space. A comet, maybe you could tell the people the difference between a comet and an asteroid, because you often look at asteroids.
So the original difference here is just comets are things that are seen to have tails. That's literally it. Asteroid means star-like thing, is the point. It doesn't have anything coming off of it. But then the categories get a little bit fuzzy on the edges, because we see this whole category of things called main belt comets. They're on orbits in the main asteroid belt. They look like asteroids most of the time. Every so often, they start spraying out tails like comets. We infer these are objects that had a lot of ice in them initially. They migrated around in our solar system, came in a bit. They lost most of the ice on the surface and evaporated away. And then every so often, a patch of ice gets destabilized and evaporates off and carries dust with it, and that makes a tail. So
they morphed.
Comet versus asteroid, sometimes the boundaries are fuzzy there, but Borisov at least looks a lot more like the outer asteroid belt, like the Halley-type comets, than it does the asteroids in the inner asteroid belt.
Okay, so
Oumuamua, on the other hand, is looking more like a rock, although it apparently outgassed a little bit of material when it came very near the sun.
Well, it would have changed its velocity
Just a little bit because material's coming off.
Okay.
That's a tricky thing with Borisov, actually. The orbit predictions I'm giving you are a little bit uncertain because it is jetting out material. And it's changing its velocity very slightly, but it's very small in comparison to the very high speed it has relative to everything else.
All right.
So it's going to keep mostly to the orbit we've got it on right now, but it'll move around a little bit.
All right. Well, I think we're going to wrap this up. My last question to you, so obviously, I mean, comets can turn into asteroids, but I guess asteroids don't turn into comets.
There's an exception to this. You bring them really near the sun, then they get really, really superheated, and then they start breaking apart.
But so you might get a tail.
Yes.
The defining characteristic of a
Then there's a group called the Manx comets, which are named after those cats that have no tails.
Well, so better known as asteroids. Are those Manx comets? Okay. Well, finally, you're here at the SETI Institute. You've got an office over here. You're sitting there during the day, and these things come along, and you think, man, rock and space. That's one of the things I study. What are you planning to do personally about this object?
This one, stuff I do, I cannot do that much with it. So I'll be off observing near-Earth asteroids while other people are observing this one.
Well, you're at least protecting the Earth.
Now, again, should some of these things be close enough, there's techniques I do to actually be useful. I would be very happy to try, but not an option here.
No, that's too
For Oumuamua, we could have tried to do radar observations and get detailed images of that one, but we would have had to have observed it 4 days before it was discovered, which was, again, not possible.
You're just too limited in your thinking. All right.
I can't send stuff back in time, sorry.
Well, if you can, Michael, come see me in my office. I want to talk to you about patents. Michael Busch, thanks so very much for being with us. Thank you for being with us. I'm Seth Shostak here at the SETI Institute. We'll see you next time for SETI Live. What do we call this? Facebook Live. SETI Live, do we call it anything? Have we given this program a name? Should we have a contest?
Sometimes we call it Facebook Live.
Facebook Live. Well,
Facebook Live.
oh, Spacebook Live. Well, that's very clever. If you have a better idea, why don't you send it in? We will send you, as an indication of our gratitude, an autographed signed photo of Rebecca. So do that. And meantime, hang in there, and we'll see you next time. Bye-bye.